All right, part two to solving systems of equations. So the other technique I'm going to teach you to solving systems of equation is called substitution. So when we substitute something, we're going to plug in something else. So I'm just going to go right into the examples because I think it'll make more sense when you see it. So first example, solve for the solution for this equation. Now, what I need to do is I need to isolate for one variable. And I want to choose the one that's the easiest. So if I take a look here, I think it's easy to isolate for this one variable here, x, um, and uh, and then we can um, plug it in to the other equation. So I want to get x by itself, and you're going to see why I'm going to do this. So I want to get x by itself, and to do so, I'm going to isolate. So the opposite of adding 2y is subtracting 2y. And what I do to one side of an equation, I'm going to do to the other side. So I'm going to subtract 2y here. So these are opposites. And what I end up getting after I do that, I should Command C, is I get x equals 2 minus 2y. It doesn't matter if you put the y in front or after. There's no reason to do that. Now, this is how we substitute. I am going to take x here, because x is equal to something, and I'm going to plug it in for this x right here. So this is what I'm going to do. I'm going to substitute it. So if I were to rewrite the equation after substituting, instead of x, I'm going to put in what it's equal to, which is 2 minus 2y. And then I keep the equation the exact same. So all I did was plug it in. So instead of having an x, I plugged in 2 minus 2y, plugged it in here. And now what I'd like to do is I'm going to isolate for y. I want to figure out what y is equal to. So before I do, I'm going to distribute this 3 to everything in the bracket. So what I end up getting is, well, 3 times 2 is 6. 3 times 2 is 6. And negative 2 times 3 is negative 6. So I end up getting 6 minus 6y plus 4y equals negative 4. Now you guys can hopefully see that we have some like terms here. So we have negative 6y and plus 4y. So what I end up getting when I combine those like terms is negative 2. So I get negative 2y, 6 minus 2y equals negative 4. Now we're going to get y by itself. So to get y by itself, we want to isolate. The opposite of adding 6 is subtracting 6, because remember there's a plus here, right? What I do to one side, I do to the other. These are opposite, so I cancel these out. And now I'm left with negative 2y equals negative 10. And what do I do to both sides to get y by itself? I need to divide by a negative 2. And what I do to one side, I do to the other. And I am left with, because these are opposites, negative 2 divided by negative 2 is 1, not 0, but 1. And I'm left with y equals negative 10 divided by negative 2 is 5. So I'm not done yet. That's what y equals to. I don't know what x is yet. So I'm going to plug this guy in for, if I keep going here, I'm going to plug it in any equation. It doesn't matter. I'm going to plug it in for y. Okay, so if I were to take this equation and plug in 5 for y, I will end up getting, doesn't matter which one. I could have plugged it into this one, or I could have plugged it into this one. So I'm just going to change the color of this so it's not so confusing. Let's make it black. So what do I get here? I end up getting 3x plus 20. So 3x plus 20 equals negative 4. And then 3x, what do I do to both sides here to get x by itself? I subtract both sides by 20. So subtract this side by 20, subtract this side by 20. So I get now negative 24 on the other side. That cancels out. Negative 24, and then I divide both sides by Sorry, I'm just going to move this over grade 9. And then what I end up getting is if I divide both sides by 3 to get x by itself, I get x equals -8. So my solution, that's my x, that's my y. The solution to this system is my x is -8, my y value is 5. And that is all. Okay. Yeah, you guys can practice that. That's all it takes. That's all it takes. I'll actually do one more example just in case. So in this one, I need to find a variable that it's easy to isolate for. So the easiest one to isolate for is here, this y over here, because it's already by itself in a way. So I'm going to subtract 4x from both sides, subtract 4x from both sides, and then I'm going to get y equals 5 minus 4x. So 5 minus 4x is what y ends up equaling to. Okay, so now I have this equation, and I'm going to plug in this y in for here, okay, to the other equation. So if I do that, I end up getting 2x minus 4, and instead of y, I'm plugging in 5 minus 4x. So now I isolate for x. So again, I distribute. So distribute here. And then I end up getting -20 plus 16x equals 7. Again, I have like terms. I've got 16x and 2x. So when I add those together, because this one's a positive, there's a plus in front of it, I get 18x minus 20 equals 7. So what do I do to both sides? I will add 20 to both sides, again, to get x by itself. Add 20. And what am I left with? 18 equals 27. And then divide both sides by 18. Okay. And then I get, where am I here? X equals, I can divide those both by 9, so I get 3 over 2. 3 over 2 is the same thing as 1.5. Okay, now what do I got to do? I got to take 1.5 and plug it into any equation. So I'm going to plug it into this one here. So I got to plug it in for x because that's what x is equal to. Okay, so if I plug it in there, I end up getting, just copy this guy. So I end up getting 4, instead of x, I'm going to put 1.5 plus y equals 5. If I want to get y by itself, I need to, well, first, what's 4 times 1.5? 6 plus y, and then to get y by itself, I subtract by 6 from both sides, and then I end up getting y equals -1. So y equals -1. Ooh. My solution to this system is my x value was 1.5 and my y was -1. That's it.